Hello everyone, welcome back to channel Geek Nepal. My name is Subhas and today I'll be working on the coordinate conversion instruction, which would be XYFS, CVXYT, YTX. Okay. Alright, let's begin by adding a normally open contact and let's make this M8125. If the PLC is in operation mode, we want to make a table for X and Y coordinates. S1 is a format number which would range from 0 to 7. The maximum would be 8. Okay, so you can have 8 different lines of linear relationship between X and Y. So the value of X would be ranging from 0 to 31, so total of 32 data points. Okay, same for Y. Let's make this 0 0. If the value is 5, let's make Y equals to 10. When the value of X is 10, let's make it 15. Okay, so that would be Y equals to 2x, right? Okay, so let's say we have 3 different points here and we have 3 different data points already, and XYFS can be used for integer and word. Okay, when the input output memory internal relay are used, 16 data points are used, while timer and counter and data register are used, only 1 point is used. Okay, already, and when the input is on, what happens here? The device is in operation mode. Okay, and it will start making a table. Okay, basically. Now we want to convert X value to Y based on this format. Okay, on the table above. So let's add a normally open contact, and let's say this one is I0. Okay, let's drag and drop, convert the value of X to Y. Okay, and we want to convert the value of 8 X value to Y. Okay, and set that to D0. Okay, here do not get confused with D1 and D000. D1 is a destination register, whereas D00 is a data register where we will save the Y value, converted Y value. Okay, let's add a normally open contact, and this would be I1. Okay, and we will be converting Y value to Control Z, zebra. Okay, already, and same thing here, and we will convert 12 to X value and save that to data register D3. Okay, already, let's go ahead and simulate this program. Okay, already, initially the value of D1 on data register D0 and D3 are 0 0. When the input is on, the value of X is converted to Y. Okay, so that would be data point 8 and 13. Similarly with Y value is 12, that is converted to X value 7. Okay, that's how it is done. Alright, now we will work on the averaging function. Okay, alright, save this. Let's open a project 20. Already, we have an average function. What does this average instruction do is it averages the moving data points. For an example, if we have a temperature that's being rising or going down, or the pressure that is going up and down, we will take the average of some time and we will use that scaled value. Okay, alrighty, so how do we do that? Okay, alrighty, let's go by. We do not have the analog input for temperature or pressure sensor. Okay, so we will be using timer, which will be moving. Okay, so let's do a input I 0. Okay, that will activate a timer. Okay, let's go to basic instruction, timer. Okay, let's say it's a timer T0, and let's set the preset value of timer is 500 millisecond. 500 times 100 milliseconds. Okay, and onto the next round, I want to add a normally open contact and M8125. Okay, we want to do an averaging, right? Let's drag and drop average instruction. Okay, and onto the third row, I want to add a normally open contact. That would be I2. Let's say when the input is on, the heater will be on. That's the plan. Okay, for an example, and that would be Q0. Okay, already, let's go and see the average function. Average function can be applied to word, integer, double, long, and float. S1 would be the analog inputs, okay, or timer. S2 would be the input that will activate calculating the averaging function. Okay, if it is a timer, you do not have to use S2. S3 would be the scan time. Let's use 500. Let's say this one is I2 input, and this one we are using timer. Okay, so, and D1 would be the destination register where we will save the value of average. Okay, to data register D11, let's say D11. Okay, and M0 will say the output has been up. Okay, already, now let's simulate the program here and we will see. Initially here, okay, now let's do this time. Once the timer is moving and the input is on, the averaging is just doing nothing right here. So when it's off, so the averaging is moving. You can see that, because since it's a timer, it's going up, it's going to 0 and going to up to 500. Basically it's showing you the average of the timer. Okay, that's what is going on. Okay, so in sum up, we did work on the convert from X to Y or Y to X. Okay, and an averaging instruction. For an averaging instruction, the CS1 is a source 1 that could be any sampling data, input or output, those kind of values. S2 would be a sampling and input. Okay, and already, and S3 would be our scan time. Okay, sampling cycle. D1 is a destination. Here the average would be stored. D0012 will save the maximum, and D0013 will save the minimum number. Okay, if S3 is 0, the average instruction turns on and off based on the input. Okay, so we are done with the conversion instruction. I will see you on the next. Thank you so much for your time.